Alright guys, this is problem 8 of the AMC, the 2018 AMC 10 Test B. And this is taken straight from the Art of Problem Solving website. And so I'm here to just tell you how to solve it, okay? And there's one of two ways to solve this. I kind of naively solved it by doing it the long and hard method, but there's an easier way to it, alright? And I'm going to show you my thought process. So it says, Sarah makes a staircase out of toothpicks as shown. This is a 3-step staircase and uses 18 toothpicks. How many steps would be in a staircase that used 180 toothpicks? Alright, and here's how to do it, alright? And so when I look at a problem like this, I immediately think of patterns, alright? How would I establish a pattern of toothpicks, alright? And so let's create our own table here, okay? I don't know why that just happened. But alright, here. So if we have one toothpick, or if we have a one-step staircase, how many toothpicks do we need? Well, we'd need 1, 2, 3, 4, and there we go, one step. So we need 4 toothpicks. Alright. If we had a 2-step staircase, well, we'd need 4, 5, 6, 7, 8, 9, 10. You need 10 toothpicks. Alright. So 2 staircases, 10 toothpicks. If we had a 3-step staircase, well, it already shows us here 3-step, 18 toothpicks, alright? So 3, 18. If we had a 4, alright? If we had 4, so here, let me just draw in the 3. If we had a 4-step staircase, well, we'd have 18 plus 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, alright? And here, that is all we need, alright? And so now let's try to establish a pattern, alright? Let's see what we have. We have 4 to 10, that's increasing by 6. We have 10 to 8, that's increasing by 8. We have 18 to 28, that's increasing by 10, alright? So we're going 6, 8, 10. And we can obviously see from this, I can never say obviously. Obviously, alright, there we go. So we have 6, 8, 10. Then we can obviously see from the next pattern we'd have 12, 14, 16, 18, alright? We're just going to keep adding on to that, okay? And so what I did, I went down. So I went 4, 5, and then 28 plus 12 is, hold on, let's draw a line all the way down. 40, or 28 plus 12 is 40. Then I went 6, and then 40 plus, alright, 40 plus 14 is 54. And I went all the way down to 180 to find our answer would be 12, alright? But there's another way of doing this, alright? If you're good at analyzing these types of tables, you can find a certain function first, alright? And so to find a function for it, we have to see what type of function. Is it going to be linear? How is it going to be, alright? And so I found it's going to be kind of like a quadratic function, alright? So if we have right here, we have, oh, I'm sorry. Yeah, if we have a graph right here, right? If we graphed out and plotted all these points, we'd have 1 right here, for example. We had a 4. We have 2, and then we have 10 somewhere right over here. We have 3. We have 18 all the way up here. Right? And if we just connected all that, we'd see that it'd be a quadratic function, right? And we could obviously go left like this. Oh, I'm sorry. We could obviously go left like that and have the same thing. This is just a rough sketch. It's really not exact, alright? But we could obviously go like that, and we'd see that it'd be quadratic, but we're just using the values to the right for now, okay? And so we know it's a quadratic function, alright? Now, what exactly would it be? Well, if you did certain manipulations, if you're good at this type of stuff, then you could find that the function would be n plus 1 times n plus 2 minus 2, right? And you'd get your value, right? And the reason why it's this one right here, right? Let's just start plugging values, right? If we plugged in the number 1, let's plug in 1. 1 plus 1 is 2. 1 plus 2 is 3. 3 times 2 is 6. 6 minus 2 is 4, right? And we can keep plugging in values and get our y value, or our toothpick value out of this function, right? So now that we have established that this is the function, I know this video is going kind of quickly, so just rewind if you're having trouble, okay? So we have this thing right here is equal to 180. Alright, now let's solve. Add 2 on both sides. Alright, we'll just do that. and then we can change this to 182. I'm just going to write over it like that. 182 is equal to this quadratic right here, right? And so then you FOIL all this out, you get n squared plus 3n is plus 2 is equal to 182. Subtract 182 on both sides, you get n squared plus 3n minus 180, alright? And so now what we're trying to find is, we're trying to find what two values of a negative 80 what two factors of negative 80 are going to multiply to a negative 180 and add up to 3. Well, negative 12 and 15 do that, right? Negative 12 times 15 is negative 180. Negative 12 plus 15 is 3. Alright, so we can write our function like this. Wow, this is very ugly right here. So we have n minus 12 plus n plus times n plus 15, alright? And from here, we only wanted to take this positive solution, right? Because we know we can't have negative toothpicks. So our positive solution would also be 12 in this situation. And there we go. 12. So when you see a problem like this, when you have something gradually increasing, you want to first notice, is there a pattern? Do I see a pattern in between this? And in this case, we did see a pattern, all right? And once you establish the pattern, try to make a function out of it, all right? That's the easiest thing. Or if you can't make a function out of it, try to follow the pattern until you reach your answer. All right? I know this video went a little bit quickly, all right? I talked kind of fast, but I think there we go. That's how you solve it.